Hey everyone, good morning, good afternoon, and good evening. My name is Vishwadeep, and I welcome you all on PW Gatewala channel. In the last class, we have discussed the last and very important algorithm, round robin algorithm, from where a lot of questions have been asked in GATE examination. Now, today's class, we are going to discuss two more types of scheduling algorithms called as multi-level queue and multi-level feedback queue scheduling. Okay, what these algorithms are. Before that, I would like to have a question which has been asked from many students many a times. Sir, when we design an operating system, in an operating system, only one particular type of algorithm is implemented for CPU scheduling, and I always say yes. But see what happens. If let's say you implement priority based algorithm, you can take the advantage of only priority based algorithm, real time response. If you implement, let's say, round robin, then you can take advantage of round robin algorithm, interactivity. If you want to implement some other algorithm, you can take advantage of other algorithm only. Sir, I want to take advantage of multiple algorithm together. Can I implement it? My answer till here is no, but now onwards I can say yes. How, sir? If you want to take advantage of multiple algorithms, then what you need to do is going with this type of scheduling. What it says, multi-level queue scheduling says that we will try to implement multiple scheduling algorithms in a single system. How? For that, it says that you create multiple ready queues based on some behavior of the process. Whatever you decide, whenever processes are coming, based on its type or behavior or execution time or whatever, operating system will decide that this process will go in this ready queue, this process will go in this ready queue. And to execute processes of different ready queues, you can use different scheduling algorithms. So I'm writing that particular definition. Multi-level queue scheduling says that processes are kept into multiple ready queues based on their types or behaviors. Okay. And for executing processes of each queue, a separate scheduling algorithm is used. Okay. One of the very common way to distribute the incoming processes into different queues is based on type. The process, if it is part of system process like driver, etc., then that those processes are kept in some other queue. The processes which are visible to user, like user processes, like Adobe PDF reader or Microsoft Word or music player or something. Those are called as foreground processes which are visible on the screen. Then there are so many background processes which are not visible. Their response is not visible on the screen, but running in background. Those are called as background processes. So foreground, background, system, like this, we have type of processes, and for each type of processes, we have kept three different type of scheduling queues, ready queues. So one ready queue is this one, system processes. Another ready queue is this one, and another ready queue is this one. Now to run processes of system process queue, we can implement or we can use one algorithm, let's say round robin with quantum 2. To execute foreground processes, we are using some other algorithm, maybe SJF or SRTF or maybe FCFS. For background processes, we will be having different type of scheduling algorithm. This is how we can do what? We can implement or we can use multiple scheduling algorithms in the same system. That is multi-level queue scheduling. Now, the thing is how we will decide that next process we will have, means operating system will decide how, the scheduler will decide how, that which queue's next process will be taken. So there are two ways to do that. The first one is fixed priority preemptive scheduling method. Second one is time slicing. Fixed priority preemptive scheduling method says what? It says that you give priority to this and this queue. Priorities are given to the queue, not the process. Okay, to the queue. So let's say this is highest priority queue, then next and next. So queues are getting priority, and after that, what we will decide, highest priority queue processes to be scheduled first. Run all the processes of this queue. When all the processes of this queue are done, then only we will run all the processes one by one, whatever the manner is of this particular queue. Once all the processes of this queue and this queue, both queue are done, then you will run the processes of this queue. This is one of the common way to run the processes of multi-level queue. So I'm writing that particular part here. Assign priority to each queue and run, I should say, schedule all processes of highest priority queue before scheduling any process of next priority queue. Now, in this case, the thing is, let's say system processes, two processes are there. One by one, you have run them based on whatever algorithm. Now, one process is there in the foreground process. That process is currently running. Okay, running. While running the process of queue number 2, let's say any new process arrives in the queue number 1, which is higher priority queue. What happens? Preemption. This particular queue's process will be preempted. I don't care that what kind of algorithm I am putting over here. Let's say for running this particular foreground process, we are using FCFS algorithm. Why FCFS algorithm? If I am running P3, which is this queue process, this process not completed yet. We know that FCFS is non-preemptive, yes, but the thing is FCFS is just for this queue, not for other queue. If in the higher priority queue a process comes, then whatever algorithm you apply over here, because of the difference between the two queues, this arrival of new process in the new queue, the higher priority queue, P3 will be preempted. If new process comes here, no preemption happens. Just because in this queue, locally we are having FCFS. Current process will complete. Then only next process will be scheduled. But if higher priority queue will have a new process arrived, in that case, definitely you will have to have what? Preemption. Okay. So we'll have to write that particular thing. That's why it is called as fixed priority and preemptive scheduling. The queues are having fixed priority, and between the queues we'll have to go with the preemptive nature. If while running a process of low priority queue, A new process arrives. A new process arrives which has, okay, new process arrives in higher priority queue. Then the current running process will be preempted for sure. Does not matter if to schedule that current running process you have used some non-preemptive algorithm. Non-preemptive algorithm is just for this particular queue. If new process arrives here, I will not preempt. But if new process arrives here, I will preempt. Okay. Second is time slicing. Time slicing is very easy. It is something like give time to each and every queue for executing their processes. Wide time slice to execute processes of different queues. You don't have to give them equal time, huh? You can decide something like this. Okay, let me know. Look at this. You can decide something like this, that if, let's assume, you are running Q1 processes first for 50% time, and queue number 2 processes you are executing for remaining 30% time, and queue number 3 processes you are executing for 20% time. So you don't have to give time slice to each queue equal. Run 50% time processes from this, 30% this, 20% this, and again repeat. Then again next 50% processes of this, next 30% time process of this, 20% times process of this. This time is what? It will be decided based on the factor. Let's say in 1 millisecond or 1 microsecond, 0.5 microsecond queue number 1 processes, 0.3 microsecond queue number 2 processes, whatever processes in whatever manner based on that queue scheduling. And queue number 3, 20% time. Okay, now I will have a question for you guys so that you guys can understand. Look at this. Scenario is given, processes are there, their arrival times are given, their burst times are given, and given that in which queue those processes will be arriving. Two queues are there, Q1 and Q2. Round robin is used in Q1. So to run all the processes of Q1, we will have to use round robin with quantum 2. And to run the processes of queue number 2, FCFS is used. Okay. And Q1 is having higher priority. Good enough. Let's have the Gantt chart. Fine. I will have the ready queues here. Now I will be having multiple ready queues. Queue number 1, queue number 2. At time 0, in queue number 1, look at this. Queue number 1, at time 0, two processes already arrived, P1 and P2. So P1 and P2 are arrived at time 0 in queue number 1, and at time 0, only arrival time 0, P3 arrives in queue number 2. So these three processes we have. We are solving this question by this fixed priority preemptive scheduling. Okay. I am solving this question by fixed priority preemptive scheduling. So at time 0, you tell me which process is to be executed. At first place, we will have to execute all the processes of queue number 1 first before any chance comes for P3. No. No. Yes. Understood. What am I saying? No any process of queue number 2, which is lower priority process or lower priority queue. You cannot run any process of that queue until you will run all the processes and finish the queue number 1 processes completely. So queue number 1, two processes are there, P1 and P2. Let's run them. So we'll run them. P1 runs for quantum 2 time unit, remaining is 2. Then P2 runs 2 time unit, 4, remaining is 1. Then again P1 runs, new process arrives at 9. So I don't have to worry a bit. Okay, right now you don't have to worry. So P1 runs again 2 time unit, 6, and P2 runs 1 time unit till 7. 7 time unit, P1 and P2 done. P1 and P2 over. Now, no any process is there in queue number 1. Fine. Now, we can say queue number 2 process can get the chance, P3. P3 will get the chance. But please remember, check out this. You guys are smart and I can understand that. I can understand that you guys are understanding even before I tell you. Sir, at time unit 9, a new process arrives in queue number 1. So at time 9, process P4 arrives in queue number 1. So what happens? When P3 is running, which is from queue number 2, even though it is having FCFS algorithm, whichever comes first in this queue should run first. I have scheduled that, but till 9 time only it will run. Only till 9 time. Why? Why, sir? At 9 time unit, in the higher priority queue, Q1, a process is arriving, which is P4. And if a new process arrived in the higher priority queue, preemption happens of the lower priority queue process. So P3 will be preempted and P4 will be given the chance. P4 will run for 4 time unit till 11, then again till 13. Quantum 2 and then quantum 2. It will completely execute single process. Then after that again P3 will get the chance. P3 you have run for 2 time unit here, 7 time unit remaining. It will run at the end. Just check out quickly if any kind of issue is there. So many students get confused over here. Sir, P3 we are executing through FCFS. In FCFS algorithm, so there is no any preemption. Yes, beta. Am I preempting the process P3 just because I do have a new process in queue number 2? Am I stopping process P3 here just because a new process comes in Q2? No. If a new process comes in queue number 2, I won't care. Just because FCFS says don't preempt this current running process if a new process arrives in queue number 2. But just because we have two different queues with two different priority, here preemption of lower priority queue process will happen when a new process arrives in the higher priority. Understood that? Okay. Now, the next thing is, what are the advantages and disadvantages? We have two disadvantages here. Some processes may starve for CPU if some higher priority queues are never becoming empty. System processes are keep coming until system processes are done. You cannot run foreground processes. Then you cannot run background processes. Hence, you will have to understand this fact that if higher priority queue is not getting empty, lower priority queue processes you will not run, and hence those processes may go into starvation. Yes. Second is inflexible. Inflexible in nature means once a process is kept into a queue, let's say queue number 2 or 3, it cannot be changed. It cannot be moved below or above based on its current behavior. It cannot be changed. So it is inflexible. There is a solution of this. Yes. Solution of this issue is next algorithm, multi-level feedback queue scheduling. And this is what used in all the modern day computer systems. So multi-level feedback queue scheduling is nothing but it is just a little advantage, or I should say a little advancements, extension of multi-level queue scheduling only with extra feedback. So what it says, same as multi-level queue scheduling, only change is processes can be moved between queues. Means we can move a process from low priority queue to high priority, or high priority queue to low priority, based on the behavior of the process between the queues, based on some factors. So what will happen here is a small change. The processes can be moved up and down based on some behavior. Sir, can you please explain some kind of example? Let's say we have a process here in foreground, processes. That processes, or that particular process is waiting since long, very long. So if its wait time is too much, it is not getting the CPU, then it will be moved up so that it can run. So if process is waiting for longer time, it can be upgraded to above queue. Let's say there is a process here and which is running since long. Let's say round robin scheduling we are using here, and in the round robin it has been running since long but still not completing. We can downgrade it so that other processes can get the chance and they can complete. So there are many such kind of factors. These are some examples I have made, but there are many such factors with the help of which we can decide that a process can be moved up or down based on the feedback, based on the behavior. This is what multi-level feedback queue scheduling. If somebody asks you in the interviews, all modern day computers using this well. So they have a round robin scheduling for running different processes with different time slice, and of course priority also. The process which user wants maximum attention to should be in the highest priority queue so that it can run quickly and more of the time. Fine. Here also starvation may occur. One process is running over here, not running, waiting, moved up for some time, it runs and again moved down. Why? Because of its behavior. So it might possible that your factors may keep a process in the downside queue, upgrades it for certain duration of time and again downgrades it. So again process will wait. So because of that, process may go into lot of waiting. Starvation is possible, but advantage is flexible. The processes can be moved from one queue to another queue. Of course, their behavior, initial behavior will not be same. It was a foreground process, but it has moved into other queue, possible. It will not become system process. It will still be a foreground process only, but we have moved its queue. Why? Just because we wanted it to run. That's why. Okay, fine. Okay, so this was it. We wanted to have a quick discussion about these two types of algorithms so that I could have given you guys this particular class. Next class, whenever we will meet, we'll be having some questions, different type of questions which have been asked in gate examination from these scheduling algorithms. So one practice session we are having next one. Before that, you guys are having enough time. Please go through these lectures, all the scheduling algorithms. Keep the notes ready and we will solve some questions live in the class so that you guys will have some idea what type of questions, different type of questions can be asked in the gate examination and how to solve them. See you in the next session. Till then, have a great day. Happy learning. Bye-bye.